All right, let's look at histograms. And histograms are one way to represent what quantitative variables look like. And if you remember, quantitative variables have the letter N in them. A quantitative variable is a variable in which numbers act as numerical values. The data you have always is going to be a number rather than a word. There's a lot of ways we can display quantitative variables, and we're going to look at these histograms first. So histograms are a representation of a frequency distribution by using rectangles of the same width, the interval, and varying heights to show the proportion of the total in each class. So it's a way to look at information, right? So between 0 and 1 in our first bin, you have a height of 1. So how many times was the number 1 in the set? Once. The next one is going to be a 2. Between 2 and 3 is 4. Then 2, 1, 1. And the class interval, how wide is each one of these? Is 1. So not a terribly exciting example, but I'm just reading the histogram that was given to answer these questions. And I know it seems kind of weird. We're looking at the left-hand side. So between 0 and 1, 0 less than or equal to. So how many times did 0 show up? That's going to be equal to 1. Okay, scrolling down a little bit, something with a little more information. So let's say that all of this data we have represents the age of someone's relatives, right? So you ask, how old are all your relatives? They give you all of these numbers. This represents all of their ages. And we're going to put that into a histogram. So on the left-hand side is going to be the number of relatives that we have. And that's just going to go up by ones. And across the bottom, I don't want to have to plot every single one of those numbers. It's going to be way too much to put in there. So we're going to put them into interval ranges of 10. And to give myself a little bit of width here, I'll say here's 0 and 10, 10 and 20, 20 and 30, 30 to 40. My biggest number is 49, so then I'll go 40 to 50. So these go right next to each other. There's no space in between them. And I'm going to start looking at all of my data here. The first one, there is only 1, 3, 11, 12, 19. So there's 3 in this bin. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1, 3, 6. Between 30 and 40, looks like there is 1, 2, 3. And you don't have to do the tally marks. Like if I was going through it, I might need to do that. So 45, 49, there's 2 in there. So I want to take this data frequency chart and put it onto my histogram. The first bin between 0 and 10, we're only going to go up 1. And across the bottom, we're going to say this represents the age. I need to make sure I label that part of it as well. And as far as a title goes, this would be the age of my relatives, the ages of my relatives. Between 10 and 20, we have 3 marks. So go up 3. It's going to shade in the other direction so they don't blend together too much. Between 20 and 30, we've got to go up 6. So 3, 4, 5, 6. I'll shade back in the other direction. They don't all have to be different designs. I just want to make sure as they're right next to each other, they don't bleed together too much. The next one is going to go only up 3. And the last one is going to go up only 2. So now as I look at this histogram, it gives me a nice representation of the ages of all of my relatives. Not every specific one is in there individually, but I can see in these different bins of 10 how they all fit together. And then as you look this, where is the center of this one? It looks pretty evenly matched left to right. It's a little bit low on the left end, but it's almost like a perfect, what we'd call a bell-shaped curve. And so I would say the center is right around that 25 number, right between 20 and 30, which looks pretty accurate to what we have up here. And if it is nice and even like that, a lot of my calculations that we'll do with some of their numbers, like with the measures of central tendency and so forth, match up pretty nicely. So how would you find the center? What center would you want to use? We talked about these measures of central tendency. Anytime that the data is nice and symmetrical, then the mean should be equal to the median. So I'm talking down here at the bottom as well as up at the top. The last graph that we had was nice and symmetrical. left to right, then we're going to use the central tendency of the mean because it's probably equal to the median as well. However, if the information is skewed to one side, we're probably going to want to use the median for the better measure of central tendency. In other words, if it's skewed to the left, so if my graph looks like there's more on the smaller end than on the bigger end, I might have some outliers that are over here, some numbers that are really big that don't seem to match with everything else. I'll want to use the median to get the better measure of central tendency. The mean is further to the left than the median would be. And if my graph is skewed to the right, so all of a sudden it looks something kind of like this. I might have some outliers that are on the left-hand side. Then again, I'd use the median rather than the mean to find the best measure of central tendency. So a big takeaway from this, if we go back to the histograms, is having a interval range that displays all the information, so I don't have to put every single number on there. When there is a nice range like that, we can get a nice visual picture at the very end.